Welcome to the JPA Challenge. In this challenge, you'll be working on your own, but starting with the existing code in the JPA project, you'll create a new JPA entity to include song data when an artist is retrieved. You'll also create a JPA query using JPQL to retrieve songs that have a specified word or phrase in them. The summary of steps you'll need to take are listed on this slide. I'll review these in more detail shortly. First, create a new entity named Song for the Music Songs Table. Next, edit the album entity, adding a list of your song entity as a field with appropriate annotations, and include this list in the toString output. You'll next edit the main class, retrieving a single artist by ID, confirming songs are now part of the artist's data that's retrieved. After this, I want you to create a song query class that's similar to the main query class from the previous video. It should include a method to query the music data, returning any artist with an album with a song that contains matching text of your choice. For example, the words storm, dead, or soul are in a variety of song titles in albums for different artists. Print the artist name, album name, and the matching song title that contain the text. When creating the song entity, you should include fields that line up with the columns in the songs table. Be sure to annotate the class in each field correctly. You can use the album entity as your guide. You'll need to create at least one constructor. You'll want to generate some getters for fields your application might need access to. Finally, you'll want to also override or generate a toString method that prints the fields of interest. For this to work properly with artist and album, you'll need to edit the album class. First, add a list of songs to the album entity. Next, use annotations to set up proper entity relationships for the new field. This should be the same type of relationship in the artist class for the albums field. Since we're only reading data in this challenge, you can skip the cascade instructions in the annotation. Lastly, change the toString method on albums to first sort songs by track number, then output each song on its own line. To test your entity, I want you to edit the main class and main method. Importantly, make sure you test a different artist ID than 202, as it's set up now because this artist's only album has no songs. Make sure you remove or comment out any code that inserts or adds data to the entities. Finally, run the main method and confirm you're now retrieving songs as well as the other artist data. Next, you'll create a new class called SongQuery that has a main method. In addition to the main method, include another method that uses a JPA query to select data from the music database. This method should use JPQL. This method should select song titles that contain a specific word or phrase, which you should pass as a method parameter. At a minimum, the data returned should include artist name, album name, and song title. Have your main method execute this method, printing the artist name, the album name, and the song title of all matches. Finally, if you want a bit of a bonus challenge, create a second method to use a criteria builder query to produce the same results. For this challenge, you should try using the multi-select method instead of select on criteria query, and research the join method on root. You'll want to use it to perform your joins. Okay, so give that a try. When you've built your solution, or if you get stuck, come back and we'll walk through my solution together. So welcome back. How'd you do with this challenge? I hope you had some fun with this and you were able to include the song entity in your JPA application. I've got the JPA project open, and the first thing I'll do is create a new song class in the dev.lpa music package. I'll start by setting this class up as a simple plain old Java object. These include song ID, song title, and track number. I will start with private int. Note that I'll make each of these private but not final. The JPA code will be setting the values on these classes, so I don't want any of these to be final. Here I'll create an attribute called song ID. Next private string, then song title. Finally an int, track number. Next I'll generate a constructor, a noargs constructor. Hopefully you remembered that a noargs constructor is required to exist for a JPA entity. Then I'll generate getters for song title and track number. I don't need one for song ID because I'm not going to be using it in my own code. If you included it though, that's fine. Finally, I'll generate a toString method and output all three fields. Now that I have a Pojo, I can turn it into an entity with annotations, starting at the top, directly above the class declaration. The first annotation is simply entity. Next, I use the table annotation, and in parentheses I specify the name of the table this entity will be mapped to, so name equals songs. I will choose Jakarta.persistence here. For each field I need at least one annotation. First, the song ID column requires the ID annotation. This tells JPA this is the primary key for this table. After this, I'll add the column annotation, and again in parentheses I specify name equals, and this time I need to put in the column name from the table, and that's song_ID. In this case, I'm not adding the generated value annotation which I had on the album entity's ID field. Since I won't be adding songs in this challenge, I don't really need it. If you added that, that's fine, especially if you want to take this code a bit further on your own time and add or remove songs. But you should know if you're only reading data from tables, some annotations aren't required. You can simplify your code by leaving them out if that's the case. I'll finish the entity by adding the column annotations. First to the song title field, so ampersand column, and in parentheses name equals song_title. Finally, I need a column annotation for track number, and that's the same except the column name in the database is track_number. So that's it for the song entity. This was a bit tedious, and you can see why code generation tools are useful to help mitigate this boilerplate part of the work. Moving on, I'll edit the album's entity class next. I'll add another attribute, a list of songs which I'm going to call playlist. I'll insert that before the noargs constructor on album. It's again private, and I'll initialize it to a new array list. I'll add annotations to this. First, the relationship one-to-many. An album will have many songs, presumably. Again, since I'll only read song data, I can omit any cascade instructions which was included on artist. Next, the join column, so here the tables, albums and songs are joined by album_ID. I need a getter for this, so I'll set my cursor just above the toString method and generate that. Finally, I want to edit the toString method on this class. First, I'll sort the playlist. There are different ways to do this, but the simplest, I think, is to call the sort method and pass a comparator derived from song's getTrackNumber method. I'll initialize a string builder variable. I'll loop through each song in the playlist. Each song will be on its own line, then indented with a tab, then the song data will get printed. I'll end the song list with a new line. Lastly, I'll include the string builder's value in the text that's returned from this method. So a comma, then songs equal, and I'll concatenate the string builder here. This configuration will just make it easier to read the songs. I've completed everything that's needed to get song data that's related to an album when I retrieve an artist. To test this, I'll switch over to the main class. In the main method, I want to first comment out artist.addAlbum there, and the system.out.println that follows that. I'll change the artist ID from 202 in this code to any artist ID that's not 202. You'll remember that 202 was Muddy Waters, and we inserted one album for that artist, but the album had no related songs. I'll just change this to 103, which is the artist ID for Madonna. I can run my main class at this point. This code runs, and I can see the songs on the album Ray of Light listed there. I can also see the duplicate album with no songs listed as well. I talked about this problem in my music database in an earlier video. I hope you can see how easy it is to add an entity in your hierarchy and get data using these JPA entities. So now the final part of the challenge was to create a new class that's similar to the main query class from the last video. I'll create a new class in dev.lpa and call it songQuery. I'll create a main method. Before I start adding code to that, I'll quickly go to the main query class and copy the getArtists JPQL method. I'll paste this method into my songQuery class below the main method. First, I'll change the name of this method to get matched songs. Now I'll remove the first statement that's commented out. After that, I'll remove the OR condition in the where clause. So now I'll set up another join in this statement. After the album alias, I'll type join playlist. Remember, we joined to the collection field and not the table, so that's the playlist. After that, I'll give that an alias, the letter P. Aliases are required because the JPA provider uses them as variable names. Finally, in the where clause, I'll match to p.songtitle. That's all I need for this method. It searches for artists whose albums have songs that contain the matched value passed to this method. Next, I'll set up the main method. I'll start with a try with resources block. Inside the declaration, I'll get an entity manager factory from the persistence type, which you've seen me do a few times now. I need to use my persistence unit, and that's dev.lpa.music. If you forget what that value was, you can find it in the persistence.xml file. Next, I get the entity manager from the entity manager factory. I'll come back to complete the try block in just a second. I just want to add the usual catch clause here. And I just remembered something. I need to remove the second call to set parameter, which we don't need anymore. Right, moving on. I'll print this data out in tabular form, so I'll do a little setup here. I want dashes to be printed under my headers, so I'll just set up a dashed string. After this, I'll set up a variable for the word I want to match on. I'll set that to Storm to start with. My results will go in a variable called matches. I'll call getMatchedSongs, passing that my entity manager instance. My second parameter needs to be a string that has a pattern, because my query uses the like clause, so I'll surround my word variable with % signs there. Next, I'll print my header columns out, formatted each lined up in left justified columns. I'll print my dashes under those columns using the same placement. My query data gets returned and assigned to the matches variable. This data returns the matching artist with all of their albums and songs in the data, not just the matched album or song. In other words, it returns artists who have an album that contains a song that contains the text, Storm. Each artist still has their full set of data retrieved. This is important to know when processing the data. I'll do this with a series of for each loops. First, I loop through the list of artists I got back. I'll set a local variable to the artist name. I'll loop through each of the albums that matched. Here I'll set a variable for the album name this time. Now I'll loop through each album's playlist. I'll set another variable for the song title. So here I need to check if the song contains the word I used in the query. Remember, the match was to the artist, but all data for that artist still gets returned. Because of this, I have to again test the song title. This time I can use the contains method to do it. I'll print the artist name, album name and song title using printf and the variables I set up. Before I run this, I'm going to edit the persistence.xml file. I'll remove the last property there, which I had added in a previous video. Doing this will make the output a bit easier to read. I'll run this. And oops, I have an error here. Let me check the log. We have a problem resolving entity name playlist. We defined that with an uppercase L for list, and it's showing as lowercase, so I need to change that. I'll take a look in SongQuery and close this log file. Yes, it's lowercase, so I'll change that. And rerun it, and it should work. Here, in tabular form are all songs that have Storm in the name, with the artist name, album name, and song title printed. My formatting looks a little weird because I left a lot of space for the album column, but if you rerun this code for the word soul, you'll see why. I'm going to end this video here. If you took the bonus challenge and wrote a criteria builder query, I'll be demonstrating this next. This challenge was a little bit tricky because I never covered joins in this code with you. Part of the challenge was to have you research this and implement it on your own. If you want to see how my solution compares to yours, or you're just curious how to include joins in a criteria builder query, then meet me in the next video.